In this video, we're putting the spotlight on the distributed tracing app. Whether you ingest your traces through OpenTelemetry or the OneAgent, this is the starting place for developers, for platform engineers, for performance engineers and SRE to understand why and where maybe your applications are not running as expected, where they're failing. So let me open up the distributed tracing app. When you open up the app, by default, it will have a very similar look and feel to many other apps. You have filters on top, whether it's around segments, where you can filter what type of data you're interested in, from which Kubernetes clusters, from which applications. You also have the ability to add filters based on any type of span attributes. So you can say, I want to only analyze traces from a particular Kubernetes workload, namespace, any type of attribute can be filtered. You also have a time-based filter. In my case here, I'm looking at the last 30 minutes, but you know the drill. You can define any type of time frame. Now, what do I like when I open up the app the first time? I get to see the time series overview. So I get to see what is my performance and load distribution of all of my distributed traces over the last 30 minutes. I can also hover the mouse over here and I can see on the right side the 90th percentile, the 50th percentile, the average response time, successful requests and failed requests. Not only can I see them and hover over, I can, for instance, also click on failed requests. And so I get to see that I have kind of an even distribution in the last 30 minutes. Now I can switch the time frame, maybe to last hour, because this is a good way to see, did we have any strange behavior in terms of failures, right? It seems evenly distributed in terms of the 50th percentile or the 90th percentile. So is there any strange behavior, any spikes that happen in a certain time frame? Now, what I also like is you can switch from time series to histogram. This is now especially interesting to identifying performance hotspots, because here I get to see a histogram overview of the distribution of my requests based on the response time. I can see that the average response time is 65 milliseconds, my 90th percentile, which means 90% of my requests are faster than 24 milliseconds, and so on. Again, what I really like as a performance engineer, I can now click on failed requests and I can focus and see that most of my failed requests are actually much, much slower than the rest of the requests, which is also very common because often requests are failing because they're waiting on queues, they're running into timeouts. Now, what I can now as well do, if this is really interesting for me, I can maybe zoom in. So you can zoom into a chart. And what will happen if you interact with the chart, it will automatically update my filters on the top, because things like response time, just as what I mentioned earlier, Kubernetes namespace, hosts, application service, they're all just attributes on the trace. And so I can filter on everything. So now I've filtered on the response time. On the bottom here, I can see my endpoints, my service. I still see successful and failed. I see for the failed also the HTTP status code. I can see where the data coming from OpenTelemetry or the OneAgent. Now, I want to show you a couple of additional things that I can now do. I'm focusing on the slow requests. For me as an engineer, it's often very interesting to then say, I want to filter or group actually by services and endpoints. So I can click on service, I can click on endpoint, I can obviously select any type of attribute here, but this is for me a great example to show you what's possible. So now I get an overview of how many requests are coming in, what's the average response time, what's the P90th, what's the failure rate, grouped by my services and also the endpoints, right? So I can easily then also, for instance, sort per failure rate, and I can see that the load generator is actually the one that is producing 100% failure rate, followed by the front-end proxy. So this gives me a great quick overview in an aggregated view. All right, so let me go back to the full table view. Another thing is, if I want to focus and I want to filter further, I can also interact with the table. Remember, I want to find failed requests. I want to focus on those. So I can hover with the mouse over a particular value like failure. I can click on the three dots and I now get the option to say, I want to filter by request status equals failure. I click on it and now filter on the top has been updated. And now I get to see all those requests that are falling into that response time frame but also that are failed. Again, further interact with the table, I can sort. I really want to find those slow requests. They come from the load generator. So let me just click on one because these are all the distributed traces that match my criteria. I can now, as you can see here, interact with the table on top. I can click on any of those and the bottom will then show me that distributed trace. Now, the trace, for those of you that are familiar with it, it's basically a collection of spans that are connected through a unique trace ID. So the first one is a span on our load generator. Then it goes into the ingress control on the front-end proxy, and I can expand further. There's another span on the same front-end proxy before it then spans out into the front-end. What is this one here? This is a backend service somewhere, and then another front-end. So you can see you can expand and go on all the way. There's a little tip here on the top left, in the top left corner next to name. You can click on the plus button, and then Dynatrace will immediately expand the full distributed trace. And you can see here, this is a quite extensive one that goes through multiple different microservices. In case you wonder about the colors, a color always means this is one service. And then a line here, as I said, represents an individual span. That means we have 2 spans on this service. We have 1, 2, 3, 4 on this service before it branches off into other services. Every time a new service is kind of part of that end-to-end trace. So the first span will also be highlighted here with the service name. So I know this is when the checkout service was entered. This is also what we call a request. So individual nodes here are spans. The root node in a service is called a request, and then we have an end-to-end trace that obviously also starts with a request. Now, this is some terminology. If you click on each or on any of those nodes, you can see here on the right side, I have 2 options. I can look at all of the attributes. So these are span attributes, all the details that have been captured by OpenTelemetry or by the OneAgent. And then I can also switch to logs. So logs by default shows me all of the logs that have been captured in this end-to-end distributed trace, making this super easy and fun to analyze. And I can also easily find the hotspot. So the hotspot here seems to be that place order service that really takes 1.92 seconds to execute. And we can then follow up a little further. There's also the order publish that takes a very long time. The checkout. So these are some of the things that are happening in parallel, and they overall consume most of the time until things run into an error. All right. So this is how you can analyze your individual distributed traces. I think I've shown you some of the filtering capabilities. Now let me show you another use case. If I go back, I cleared the filter. So I'm back now in my overview. So I told you about requests and spans. So span was every individual line. Requests are those spans that are the ones that are coming into a new service. To the first kind of the first data we capture in a microservice. I can click on spans now because one of the use cases I see often is, hey, I want to see which exceptions are being captured, or I want to see database statements, and I want to understand anywhere in my architecture where database statements are executed. So I go to span analytics. Now we have all spans that have database calls, and spans that are web requests, or spans that make any other activity. So the easiest now to filter, I can say in my filter bar, DB, there is, if I enter DB, there's like affected item count, connection string, namespace, but there's one that's called query text. DB query text is probably the statement that is executed. So I can now say, I wanna only see those spans where DB query text is a field that exists. Click on update, and here we go. Now I get to see only those spans with database queries. Now you say, where is the database query here? Well, by default, this table shows a couple of attributes or columns. I can click on the column list, and you can see there's like 401 that are still there. So what I can do now, not 401, sorry, DB, I have all of my database attributes. So I want to now see the DB query text and maybe also the operation name. I'm not an expert in database, but it's sound of like makes sense. click on confirm, and then I get to see my database statement here. Now, remember earlier we had some groupings, so I can now say I want to group by the database query, which is really cool because now I'm analyzing all of my spans that contain database query information across all of my services. And I can now say, hey, I want to see those that are the slowest. It's this particular select statement. Or I can analyze which of these statements are executed very frequently, 27,000 times the same select statement, right? And then I can additionally maybe group by your service, or by the HTTP server's name, the Kubernetes namespace, whatever you have available, right? So we can actually then see which service is making those calls. And I think this is really phenomenal. So to finish up this use case, I can see the same select statement is called 28,000 times, and 28,000 calls come from the journey service and 280 in additional from the booking service. There's this and so many more things that are possible, but if you are exploring distributed traces with Dynatrace, the distributed tracing app should be a starting point for you. You can filter, be aware that you can filter on segments, you can have the filter by here, the time filter, really great to interact with the charts, all of the filters that you have on the left here. Remember, we separate between spans and requests. You have the grouping capability, and things don't end here, which means if you want to then continue working on the raw data, or you want to create maybe some charts and dashboards out of it, you can then always say open with, and this then gets the current data set that you have here into a notebook, into a dashboard, or into an automation workflow. Hopefully this helped you, and also explore all of the other apps that we have out there, especially for analyzing and detecting root causes of problems. See you at the next video. Bye bye.